I actually did. It breaks my senses. You want to
What is happening? Talking about eating chicken feet raw? Alright. Interesting conversation. So you guys have any, it's fine. You guys have any questions from homework before we get into stuff? What was that? Yes?
45 on
45 where? Sorry?
4.1. Sorry. How do I show this?
Oh, okay. So 45, they've already done the derivative. Yeah, it's got the little calculator symbol there. Because if you try to do this one by hand, you're going to go slightly insane. Well, depending on the level you start at.
Would you want us to just show them where it intersects the horizontal?
Beautiful. So the whole purpose of this is to make sure you understand, even though you're allowed to use your graphing calculator, you still got to know what to look for.
Yeah.
This is already a derivative. So the mistake you students make is when you graph this, I really, to be honest, have no idea what this is going to look like. Well, it's going to be, actually it's going to be kind of interesting. It should look, don't even try to. It's going to look something like a dampening thing.
Yeah.
So So, because you have this factor here, which is going to decrease as x gets bigger. So it should look very roughly something like this. No, Jeff, you can do it. Something like that.
Yeah.
All right, so if you graph it. So the fact that there's always a non-zero amplitude on this, you don't even have to graph it really. How many critical numbers? Oh, but you do have to be careful. Here's the main thing that's happening. Now I'm seeing really what's going on here. This guy is really important. So if that wasn't there, it would be centered around the zero, and it would do something like that. Right? So the more I'm doing it, I think I just have to graph this thing and look at it. Because now I'm curious. So if you want to borrow a graphing calculator, drop them.
I thought you only had to give the number of critical numbers. You have to give them points too?
No. You have to get the number, but you got to know where they stop being critical numbers. So, do you know how many there are?
10.
How do you know that?
I intersect it sometimes. That's all I
That's what I think.
There you go. I like it. At some point, since this thing has been taken down by 1, at some point it's not going to hit that thing anymore. At some point it's going to get below it. I like it. So I don't know, if you haven't tried it yet, maybe I won't even put it up there. Put in your calculator. The whole idea, since this is a derivative already, critical numbers occur where the derivative is 0 or undefined. It's not undefined anywhere. So it all depends on how many times does it hit the x-axis. That's going to be a place where the derivative is 0. So really the whole point is, when does it stop hitting the x-axis? And then you just count out to there. Because you know the amplitude just keeps getting smaller. The minute it doesn't reach the x-axis, it never will again. Because it's just going to get smaller and smaller. Poor little dude. So at 0, what's the amplitude? At 0, what's the amplitude? You plug a 0 in, and you get e to the 0 is 1 times 5? 5. So the amplitude, not the function value, the amplitude at 0 is 5.
Wait, how did you get the amplitude?
So at 0, plug a 0 in.
Oh, okay.
E to the 0 is 1 times 5 is 5. So it's 5 sine x shifted down 1. At 0, the amplitude is 5. Right? The function value is -1 because sine of 0 is 0.
Okay.
But the minute I get away from x in either direction, my amplitude is going to go down a little bit. Are you guys understanding that piece? Because it's absolute value of x. So each of the negative 0.1 times 1 will be 1 over each, and it's going to be smaller than 1. So it's going to reach it, it's going to reach it, it's going to reach it, and then suddenly it's not going to reach it at some point. So that's just going to count, like these guys are saying, how many times it hits the x-axis, because this is the derivative here graph, not the function itself. So the mistake students would make is they would count all these places here, right? Do you see what I'm saying?
Yeah.
Because if it was the function, those would be where the critical numbers would be, where it's a 0 horizontal tangent slope, right?
Yeah.
But it's the derivative, so I want to see where it is 0 or undefined, but it won't be undefined. Whew. It's just that easy to explain calculus. Yes.
I have two other questions. 42 and what else? It was 42 and where is it? 54.
All right. 4-1, I guess?
Yeah, so I get the derivative, I couldn't really figure out how to factor it more. So would I just find what makes the entire thing 0, and that would be my only critical number?
Well, let's look at 42. It's got a good old arc sign in there. I like it.
So the derivative would just be 3 minus 1 over square root of 1 minus t squared.
3 minus
1 over the square root of 1 minus t squared.
you know better. I personally don't have them memorized either for the arc sign. Say again? No, it's arc sign. It's inverse sign. So
Yeah.
this is like that symbol there. It's not the reciprocal sign.
Wait,
About this one?
yeah.
Okay.
Because like towards the end, I just simplified because I got t squared equals 1 minus 1/9, and then you just simplify the 1 to be 9 over 9. So if you just got
Well, all right. So what's the next step here? Just make sure we're all on the same page. I took the derivative. How do I find the critical numbers?
You said it equal to 0. But I can't.
Or it's where the derivative is 0 or where it's undefined. Don't forget. So is it undefined anywhere?
At t equals 1.
Yes, t. Yeah, at t equal to negative plus or minus 1. Yeah. So that's where it's undefined. So there's critical numbers there.
But then we just set the entire thing equal to 0. That was what I was having problems with, because I can't see any other way to factor that.
Exactly. I love it. So that's the only places it's undefined. Now you set it equal to 0. So you got to think about where's it undefined, and then you think about where is it equal to 0.
Okay.
I love it. F and X and H and T and just there. So set this equal to 0. And that's just some algebra to do there. Our favorite. Cool. And that's all they want from you in this process. It's not asking for absolute local anything. They're just saying find the critical numbers. So as soon as you get them, you're done. Just don't forget two things to check. Where it's undefined and where the derivative is 0. Look for both. You could have the little cusp thing, right?
Okay, just for questions for this, or can we?
Are there more on this one? So you actually have to do this, but you just take that equal to 0, subtract 3, multiply by the radical thing. Cool. All right, so you take 3 minus that equals 0, so you would add that over. And just switch these around, is that cool?
Wait, okay. This is where I had a question.
Oh, yes.
So, can you take the reciprocal? Because if it's like,
Sure, all day long, you can.
Yeah.
Which is really the same thing as just flipping these.
Yeah.
So you flip it this way, you flip it that way. They both end up at the same place. Square both sides, blah, 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 blah. Blah, 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 blah. Good.
And then I had a similar problem with question 54. It was I couldn't tell if I could factor this anymore. And then if I do factor it, I have a quadratic on the bottom end.
All right, here. So for a review, and just to get part of your homework done now, if you haven't done this yet, do number 54. It wants you to find the absolute max and min values. On 0, 3, right? Yes. So take a second and do that. You guys are doing that. Let me see.
I just realized something.
Omar, are you out there? Hey. Tyler. Kristen. Oh, well, this isn't really fully relevant yet, so I'll get that. Relevant. Knowing. Same thing there. Ooh. Arturo. Hey. Oscar? Michael? Quick line. Some people I only get to see when they give a test. I try not to take it personal.
Wait,
Can it be
what about minus
2x squared minus x?
So let's see, we got x squared minus x plus 1 minus 2x squared plus x. The x's cancel. What's that? What's going on there? Come on now. Come on now. Doesn't take much to derail this. So not much. So that explains it. Real quick, the bottom. How do I know that there are no real roots?
it's
Is it quadratic? You can't factor it.
Yeah, well, how do you know that? Well, you can't factor it, but so who cares? That just means you don't have rational roots. I know there's no real roots.
Because, what is it?
like
Discriminate or something.
Discriminant, yeah. So what makes something unreal and the negative b plus minus blah blah. The stuff inside the radical. So if you just look at this, b squared 1 minus 4ac is negative 3. That's under the radical. There's no real answers to that. So there won't be anywhere where the derivative is undefined, right? Because we only care about the real stuff. We're not looking at the complex plane. Thank God for you. So the only place that it could happen in the undefined, no. So it's the only thing to check where it's 0. So that would be the top, and the top is nice, right? You can factor that bad boy easy. Cool. To finish this out, so the critical numbers you get are 1 and negative 1, and I got my endpoints 0, 3. So negative 1, I like it. You throw it out. So I just got to look at 1, and then the endpoints are 0 and 3. So I say, what's f of 0? What's f of 1? What's f of 3? It's absolute max and min, right? So that's the easier one. Absolute max and min don't care what's going on there. They just say, show me all the outputs, and I'll tell you who won. It doesn't care.
Why do you count negative
Say again?
1?
Oh, it's only from 0 to 3.
Oh.
Yeah.
So for the one that asks just for the critical numbers, we don't need to do this.
No,
right?
it just wanted critical numbers.
Okay.
This one wants absolute max and min, so part of that is finding critical numbers and then using them. So I don't have to do all that weird number line stuff when the question is absolute max and min.
Is that one a different section? Because I didn't see any more questions on that. The local max.
Yeah, that's a little in the future, but I wanted to do, they describe local max and min in 4.1. I just forgot this book puts it off until 4.3.
Okay.
Yeah. So 4.1 is a little easier than that, because there won't be any local, I don't think they have any local stuff in there.
No.
Yeah. It's 4.3 they'll do it to you. Is that cool? I mean, so when you throw in, where am I going to put 0?
In the original.
In the top.
Good. And you get?
0.
That's crazy. We throw in 1, you get? 1. We throw in 3, you get? 3 over 7? Yeah. Yep. So the absolute max occurs at 1, 1, so that's the absolute max. And the absolute min. So the max occurred in between the endpoints. It occurred at the critical point. So that happens to be a local what?
Also
You can do
local max.
Beautiful. It's an absolute max. It happens to be a local max because it did come from a critical number in the middle. You guys kind of with me? Mm-hmm. Now the endpoints won't be a local anything because they're endpoints.
Just be absolute.
Poor little dudes.
Not absolute. Just wants an absolute.
But it doesn't matter because it's just want to know the absolute. The absolute just cares about what are the outputs for the points, the critical numbers, and the endpoints, and who won. Who was the biggest, and who was the smallest? Yeah.
So would 3/7 be a local max or just nothing?
That's not.
It's not necessarily anything.
So
It just
that's my question. Like, how would you know that it's not anything?
It's not the biggest, it's not the smallest, and it's not a local max.
yeah.
So once you have an absolute max and you also have the local max, you can't find 2 local maxes. There can only be 1 local max.
No, there could all day long there could be 2 local maxes. But this question was just about absolute max and min.
That was the endpoint, and it's not the absolute max. So an endpoint can't be a local max.
Oh, right.
So
Okay.
you know,
So because it's not the biggest, and because it's an endpoint,
Okay.
not to overblow this thing.
No, that makes sense.
I could all day long have like so like at 1, it was the biggest. I could all day long have another local max, right?
Mm-hmm.
But if that was the endpoint, then it wouldn't even be in the running for a local.
Right.
And this question didn't really ask for local. All I care about is absolute. That's all I care.
Oh, okay.
I just wanted to point out that I happen to be able to tell that that's a local max because it happened in between the endpoints.
Mm-hmm.
Right?
Okay.
Yes, sir.
Number 57.
What about it? So it's the same.
I got the derivative and I just don't know if I could
Oh.
factor it or
All right.
I still need it.
So we all forgot how to solve trigonometric equations, I think, because it came up in the work before this. So 57, you've got this here. What was it, sine 2t? Yeah. And they want it on the interval 0 to pi over 2 inclusive.
Mm-hmm.
So you take the derivative. And what's the derivative going to be? 2 cosine 2t. Good. All right. I like it. That 2's there because of chain rule, right? What is cosine 2t? Do it again, sorry.
1 minus 2 sine squared.
Beautiful. And why would you convert it into that? Because the only other thing I have in this equation is sine. So I'm trying to make it look quadratic in sine. Oh, shit. So the main reason, I don't know if you remember this, and if you're from my pre-calc class, you better remember this a little bit. That angle and that angle don't agree, so there's no way you can directly solve that equation. So that's kind of motivating you to rewrite this using an identity. I want the angles to match, or else they can't work together to get the answer. I need them to match angles. So that came up in pre-calculus. So I use an identity here, 1 minus 2 sine squared. And then you distribute the 2. So let's see what we think here. We got negative 2 sine t plus 2 minus 4 sine squared t. And I want to set that equal to 0. So I can divide everything by negative 2, for example. So I get 2 sine squared plus sine t minus 1. If I divide both sides by negative 2, is that cool? That should be easy now, especially if you do what they suggested. You replace sine with s. Isn't that factorable? So that's easy. But the trick was to remember this, and this happened earlier this semester too. Whenever you have trig functions you're trying to solve, it wasn't even this difficult. It was like a sine t minus cosine t equals 0. The angles already matched. I think we actually talked about in class the one place where sine and cosine are the same, whereas at 45-degree angles. So that's why the answer was based off of pi over 4. All right. How are we doing there? Is that all right? You guys could finish that out? Maybe. And thankfully they gave us an interval so I don't have to do that funky plus 2 pi k or pi k or something when I have an infinite number of answers. You guys are looking at me like I just said, David? Alright, some of you guys are now you're getting a little more angry. Oh well. It got me. I don't care. Just entertain myself. Alright. Anything else from homework? Alright, so I want to do a real quick little example to remind you guys of what we did, and then I have a little handout that I want you guys to work on. Give you this generalization of the idea, right? So if I have some function f of x, and I find the critical numbers to be a, b, and c, so it could be where the derivative is 0, or the derivative is undefined, right? However I find them. If I plot them, and I end up getting this, and remember, you'll always remember this, because this is where I put in the wrong thing at first. I need to know what the slope is doing, because it almost makes too much sense to believe. If it's a minimum, what's the slope doing as it's approaching? The slope is negative, it's decreasing, and then what's it doing afterwards? It's increasing. So where am I going to have a minimum? Which one is going to be a minimum? Yeah, because it went down to it and up from it, so this is a min. So of course C would be, because it went up to it and down from it. So that's a max. I like it. And of course, what's up with A? It's an evil little dude, right? It says, I'm going to know about. So I could kind of give it a little, and I don't know if, depending on your pre-calc teacher, you did this kind of thing in pre-calc, not with the derivative, of course, but still, and you kind of gave a little bit of a picture of what it looks like. You can do it, Jeff. There you go. So that's the min. So see, now it's going down, then it's flat for just a second, because that's where it's 0. Then it's going down, then it's flat, then it's going up, then it's flat, then it's going down. So that is a remarkably rough sketch of what that would look like.
Crazy.
Especially if it was polynomial in nature, right? Are you guys semi with me? Yes, sir.
So A doesn't have a max or min, right?
Beautiful. It has a horizontal tangent line, but that doesn't have to correspond to a turning point. It could just say, no, I won't turn. I forgot something in my house. No, I didn't. You know.
The dark side.
And that's the person I'm always behind. What the hell are you doing? All right, so that's the idea. Let's.
Oh, it's the evolution of Darth Vader. He was going towards the dark side, and then he went back to the light, and then he died.
I like it, sure, of course. And he played the harmonica somewhere at the end. If you ever saw that. They redid the ending of Return of the Jedi. All right, that's a super geeky moment. Let's try one right out of here. So for the moment, just to let you know, I'm sort of skipping 4-2. Just for the moment, just because it's out of nowhere. 4-2 is necessary, but not quite yet. Here we go. Let's just do this. I like that one. Nice and gross. refer to as it's called the mean value theorem. It's its own little thing. It's necessary to prove some of the theorems we're going to see very soon. We haven't seen them yet, so who cares? So for this problem, I want to find the local maxes and mins. There. Stupid time. Keep on slipping. Into the future. So of course, the first step here is actually a really good first step, but I sort of skip all the time because I never worry too much about it to the end. Does anybody know what the domain of this is? The function itself.
X is greater than 6.
Can't be greater than 6 because 7 would make this complex, so it's the other one. Right?
Has to be greater
6 minus x greater than or equal to 0. When you divide by the negative in front of the x, it's going to flip. So x has to be less than or equal to 6. Alright, so it's kind of good going in to know what the domain is. If you don't think about it, as long as later you think about it, it happened yesterday to us where the domain came into play a little bit. So how do I do this guy's derivative? What do I have to use?
Product.
Good, product and then chain eventually, but the main thing is product. So you got to use product. 6 minus x to the 1/2.
Plus 1/2 x
Yes.
to the negative 1.
1/2 comes down in front of the x, times 6 minus x to the the inside is negative 1. Good. Let me stop there for a second. This is a really good example of how freaking important algebra is. So I get 6 minus x to the 1/2 minus x over 2, 6 minus x to the 1/2. There's kind of two ways to proceed here. You guys cool with that so far? Yes?
Why is it negative 1?
Oh, the chain rule, derivative of this.
Oh,
Yeah. Now it looks like. Look at beat up face. I could have left that up top and I could factor something out, or I could get LCD and put them together. Either way actually accomplishes the exact same thing, which is a little weird. So if I do the LCD route, right? Why do I want to combine these? What the hell, Jeff? What the hell are you doing?
So you can cancel like terms.
Because right now it's not factored. Yeah.
Right.
And maybe there's going to be like terms, maybe not. I don't know. And if I combine them, then it's going to have a top and a bottom. I can see the bottom 0 undefined, the top 0 to see where the function's 0. I like it. You guys with me? So factoring and LCD kind of accomplishes the same thing a lot of the time. Right? So I could look at this as a factoring problem. I could take out 6 minus x to the negative 1/2. I could take that out.
Mm-hmm.
But it's actually a little bit clearer to see what's going on if you do this. So what does this guy need?
2, 6 minus
Yeah,
x to the 1/2.
it needs that. So 2 6 minus x to the 1/2 times 6 minus x to the 1/2. Yeah, you get a whole 6 minus x off. On the bottom you get 2 6 minus x to the 1/2. And I can just put on top of here minus x. So now, like you said, I can get my like terms together. So I get 12 minus 2 minus 1, so 12 minus 3. That's nice. This problem made it way too easy. Stupid problem. So what are my critical numbers? Where is it 0?
6.
No. That's where it's undefined, so I'll accept that as a critical number.
4.
It's 0 at 4, yeah. So make the bottom 0, that's undefined, so it's a critical number. Make the top 0,
And
that's still a critical number, that's where it's 0.
Yeah.
6 and 4. Notice the domain ends at 6 anyway. Fine. Okay, cool. And now I can do the number line. So yes ma'am.
I'm just a little confused on what happened from when you went from the equals 6 minus x to 1/2 on the top to the 2 times 6 minus x minus x. right, like between the purple and the black.
Oh, okay. So I multiply this top and bottom by what it needs.
Okay.
So that times that makes a whole that. And the bottom just gets all that. And then I can, now they have the same bottom, so I can just put the minus x on top.
Oh,
Yeah,
okay.
cool. I like it. Alright. So again, bottom 0, undefined, critical number. Top 0, 0, critical number. So, for the derivative. So what's up with 6? What's up with 6? 6 is the endpoint in a way. It's a built-in endpoint. So it couldn't possibly be the location of a local anything because I can't look on both sides of it. Right?
So it might be an absolute or something.
Yeah, if this question was all about absolute, then I'd worry about it. So it's a location where it's undefined slope. This is 0 slope. So then if I check, if I put a 5 in, where am I going to put a 5 in? The derivative, good. So do better than me. So if we do this, if we put a 5 in, I get 12 minus 15 is negative over positive, right? The bottom's going to be positive, it's got to be. So it all depends on the top. So that's negative in there. You guys with me? You plug a 5 in, 12 minus 15 is negative. The bottom is always going to be positive because it's being square rooted. So the whole thing is negative at 5, the derivative. What is it at 0, for example? 0, I'm going to throw 0 in this cosine. Positive, that's all that matters. And what's the multiplicity of the top? So, I don't know if you guys know about multiplicity.
Yeah.
It's not just an old movie with Michael Keaton that you should go watch if you've never seen it. It also tells you if it goes through or not. Odd multiplicity, it changes sign. Even multiplicity, it stays the same. So that same shortcut works here for this one. Beautiful, if you remember it. So what the hell does that mean? What's happening to 4 then?
Pokemon.
It went up to it, down from it, max. Kick ass. There's a max at 4 comma what? Yeah, exactly. Plug it in the original. So it'll be 4 times square root of 2. Well, you plug a 4 in, so 4 times square root of 2. 4 root 2. Root. Maybe. If you actually graph this thing, which if I am you doing this homework, that actually might be the very first damn thing I do with any of these problems. I can't stop you from doing that, and it's actually smart to do it. It looks interesting, because just looking at this, I don't know what the hell that's going to look like, necessarily. I know what the square root looks like, and this is reversed. Times x, I don't know what the hell it's going to do, shit. Alright, so let's try to do at least one of these. Well, I took a union break.
It wants its overtime pay.
Tuesdays. So try to do number 1. Before I forget, we have a study session, a homework session in 53-541 right after class. I'm going to go to my office and upload the video and stuff, which is good. It's you guys, if anybody wants to go there ahead of me. Talk amongst yourselves as to what you guys want to cover. Yeah.
So for homework tonight, do you want us to do 4-3?
You could do parts of 4-3. But 4-3 is really getting into second derivative and what it means and graphing stuff. Yeah.
So this is 4-2?
This is 4-3. This is the first part of 4-3. But I don't agree with how the book organized itself. So.
Number 1A, what is it asking?
Show that that's true. Take the derivative and show that that's true. So just to let you know, on a test, it would so desperately suck if you get the derivative wrong, because then everything about your problem will be wrong. Because your critical numbers will be wrong, everything's wrong. So on a test, I'll do the same thing. I'll say, show that the derivative is this. So that if you're not able to, you can at least do part B, C, D, E, whatever, because you'll have what it's supposed to be. You guys understand? So even if you're not able to do the derivative, you'll lose some points for that, but at least you do the rest of the problem. Right? So I'm telling you what the answer is, but I want you to do it and show me that that's what it is. Take the derivative and show me that's how it comes out. So obviously it's after it's factored.